Hi, this is Mrs. Wiederholt, and welcome to my lesson video on polynomial synthetic division. Now let's get started. There are two ways to divide polynomials. One way is through long division, and the other way is through synthetic division. In this lesson video, we are going to learn how to divide polynomials using synthetic division. In long division, we use the whole polynomial for the dividend, and we use the whole polynomial for the divisor. In synthetic division, we only use the coefficients. When using synthetic division, the leading coefficient of the divisor must be 1. And in this example, our leading coefficient is 2. So the first thing we need to do is we need to divide each term by 2 so that we can have that leading coefficient of 1. After you divide each term by 2, you will have 2x squared minus 9 halves divided by x plus 3 halves. Now we're ready to set this up for synthetic division. For the divisor, we're only going to use the constant, and we are going to change the sign. So for our divisor, instead of it being 3 halves, it will be negative 3 halves. So you must change the sign of the constant. And I put a little box around it. You can do a full box or a little half box, but you kind of put it on the shelf. I call it the shelf. Now, the next thing we do is we start to bring down the coefficients of each of the terms in the dividend. Now, you've got to make note that we start out with 2x squared, and we skip x to the first power. So remember, we're going to have to use 0 as that coefficient for the placeholder. So it'll look like this. I'm going to bring down the 2, and then the 0 for the 0x to the first power, and then the negative 9 halves. Next, skip a space and draw a line, just like that. Now, bring the first coefficient, which in this case is 2, bring it down to just below the red line. Now you're going to multiply the negative 3 halves times this number below the line. So negative 3 halves times 2 is negative 6 halves, and negative 6 halves simplifies or reduces to negative 3. Now you're going to combine the like terms in this column right here. Now, you could say that you're always going to add. In this case, you would be adding a negative 3. Or you can say just do whatever operation you see in front of the number. So this would be 0 minus 3, which is negative 3. Now we're ready to do that process again of multiplying the number, let's say on the shelf, but this time we're going to multiply it to this number, the negative 3. So negative 3 halves times negative 3 is positive 9 halves. And so now we are ready to combine the like terms in this column. And so negative 9 halves plus 9 halves is 0. Now, if your final terms add up to 0, that means there will be no remainder. Now we're ready for the final step, and that is to rewrite this using our variables. Now, this number right here, we're going to place with x. You're always going to start out with 1 degree less than the original dividend. So our solution, or excuse me, our quotient would be 2x minus 3. Because there is no remainder, that means 2x minus 3 is actually a factor of 4x squared minus 9. It also means that 2x plus 3 is a factor of 4x squared minus 9. So our answer, or excuse me, our quotient for this is 2x minus 3. Now let's do another example. Now in this example, the leading coefficient of our divisor is 1. So we will not need to divide either of these polynomials by anything. Also, before we get started, I want us to notice our degrees, or our exponents. We have x to the 4th, we have x to the 3rd, But if you notice, we skip x to the second. So when we write our coefficients, we'll need to use a 0 as a placeholder for x to the second power. And then we have x to the first power and then our constant. Okay, so let's get this one set up. So for our divisor, we will take the constant and change the sign. And I put it in what I call the shelf. Now let's bring down our coefficients. For x to the fourth power, our coefficient is 1. For negative 3x to the third, our coefficient is negative 3. And then we don't have the x squared, so that coefficient will be 0. And then for negative 7x, our coefficient is negative 7. And then our constant is negative 14. Now skip a space and draw your line. So now we're ready to bring down the first term below the line, which is 1. So we are going to multiply the number in the shelf to the number below the line. So 4 times 1 is 4, and I place it right here in the next column. And it's positive 4, so I'm going to put a plus sign in front of it. So now I'm ready to combine the like terms in this column. I have negative 3 plus 4 is positive 1. So now we're ready to start the process over, but this time we're going to take the number on the shelf and multiply it to this term. So again, we have 4 times 1 is 4. So I'm going to put positive 4. Now we're going to add vertically. 0 plus 4 is positive 4. Now go back to the number on the shelf and multiply it by this number. So now we have 4 times 4 is positive 16. So now I'm ready to add vertically, and I have negative 7 plus 16, and that answer is positive 9. So now I go back to the number on the shelf and multiply it by this term. So 4 times 9 is positive 36. And so now I'm ready to add this column vertically. Negative 14 plus 36 is 22. Now if you notice, we do have a remainder here. So that means x minus 4 is not a factor of this polynomial right here. Okay, now let's go ahead and rewrite this in polynomial form. So I'm going to have 1x and what power? X to the what power? Remember, we start out with 1 power less than the original. So it will be x to the third power plus 1x, or plus x to the second power, plus 4x plus 9 plus 22 over, or divided by, x minus 4. Now remember, all remainders are expressed as a fraction. The actual remainder is the numerator and the divisor is the denominator. So now we have done 2 examples of polynomial synthetic division. So please, if you need to rewatch this video or rewatch it and pause as you go along, please do so. I hope this video has helped you, and I look forward to working with you again. Bye-bye.